What's in a name? Everything. The power of a name has long been immortalized in prose, poetry, and history. It is your face to the world, your ambassador of quality that reflects your ideals and aspirations. Thompson's, a name, a family, a tradition of excellence. So it is with Thompson's Toyota, where our professional and courteous staff are eager to help you drive home your dream vehicle from the largest selection of new and used Toyota cars and trucks at the best prices. And if your vehicle needs service, our Toyota factory-trained and certified service technicians have the skill and expertise to do the job right and do it right the first time. Thompson's Toyota, where you'll always be treated like family.
But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
Meteor smoke makes strange clouds. Presented by Science at NASA. Anyone who's ever seen a noctilucent cloud, or NLC, would agree. They look alien. The electric blue ripples and pale tendrils of NLCs reaching across the night sky resemble something from another world. Researchers say that's not far off. A key ingredient for the mysterious clouds comes from outer space. We've detected bits of meteor smoke embedded in noctilucent clouds, reports James Russell of Hampton University, principal investigator of NASA's AIM mission to study the phenomenon. This discovery supports the theory that meteor dust is the nucleating agent around which NLCs form. Noctilucent clouds are a mystery dating back to the 19th century. Northern skywatchers first noticed them in 1885, about 2 years after the eruption of Krakatoa. Ash from the Indonesian volcano caused such splendid sunsets that evening skywatching became a worldwide pastime. One observer in particular, a German named T.W. Backhaus, noticed something odd. He stayed outside longer than most people, long enough for the twilight to fully darken, and on some nights he saw wispy filaments glowing electric blue in the black sky. Scientists of the day figured they were some manifestation of volcanic dust. Eventually, Krakatoa's ash settled, but the noctilucent clouds remained. We're still seeing them today. It seems clear now that the dust involved is not volcanic, but rather extraterrestrial. Mark Hervig of the company GATS Incorporated led the team that made the discovery. Using AIM's solar occultation for ice experiment, we found that about 3% of each ice crystal in a noctilucent cloud is meteoric, said Hervig. The inner solar system is littered with meteoroids of all shapes and sizes, from asteroid-sized chunks of rock to microscopic specks of dust. When meteoroids hit our atmosphere and burn up, they leave behind a haze of tiny particles suspended 70 kilometers to 100 kilometers above Earth's surface. It's no coincidence that NLCs form 83 kilometers high, squarely inside the meteor smoke zone. Specks of meteor smoke act as gathering points where water molecules can assemble into ice crystals. The process is called nucleation. According to AIM data, the ice crystals of NLCs range in size from 20 to 70 billionths of a meter. The small size of the crystals explains the cloud's blue color, Small particles tend to scatter short wavelengths of light, blue, more strongly than long wavelengths, red. So when a beam of sunlight hits an NLC, blue is the color that gets scattered down to Earth. Meteor smoke explains much about NLCs, but a key mystery still remains. Why are the clouds brightening and spreading? In the 19th century, NLCs were confined to high latitudes, places like Canada and Scandinavia. In recent times, however, they have been spotted as far south as Colorado and Utah. The reason, Russell believes, is climate change. One of the greenhouse gases that has become more abundant in Earth's atmosphere since the 19th century is methane. It comes from landfills, natural gas and petroleum systems, agricultural activities, and coal mining. It turns out that methane boosts NLCs. Russell explains, when methane makes its way into the upper atmosphere, it is oxidized by a complex series of reactions to form water vapor. This extra water vapor is then available to grow ice crystals for NLCs. If this idea is correct, noctilucent clouds are sort of a canary in a coal mine for one of the most important greenhouse gases. And that, says Russell, is a great reason to study them. Noctilucent clouds might look alien, but they're telling us something very important about our own planet. For more news about clouds, alien and otherwise, visit science.nasa.gov. Mysterious Objects at the Edge of the Electromagnetic Spectrum, presented by Science at NASA. The human eye is crucial to astronomy. Without the ability to see, the luminous universe of stars, planets, and galaxies would be closed to us, unknown forever. Nevertheless, astronomers can't shake their fascination with things they cannot see. Outside the realm of human vision is an entire electromagnetic spectrum of wonders. Each type of light, from radio waves to gamma rays, reveals something unique about the universe. Some wavelengths are best for studying black holes. Others reveal newborn stars and planets, while others illuminate the earliest years of cosmic history. NASA has many telescopes working the wavelengths up and down the electromagnetic spectrum. One of them, the Fermi Gamma Ray Telescope orbiting Earth, has just crossed a new electromagnetic frontier. Fermi is picking up crazy energetic photons, says Dave Thompson, an astrophysicist at NASA's Goddard Space Flight Center, and it's detecting so many of them, we've been able to produce the first all-sky map of the very high-energy universe. This is what the sky looks like near the very edge of the electromagnetic spectrum, between 10 billion and 100 billion electron volts. The light we see with human eyes consists of photons with energies in the range 2 to 3 electron volts. The gamma rays Fermi detects are billions of times more energetic, from 20 million to more than 300 billion electron volts. These gamma ray photons are so energetic they cannot be guided by the mirrors and lenses found in ordinary telescopes. Instead, Fermi uses a sensor that is more like a Geiger counter than a telescope. If we could wear Fermi's gamma ray glasses, we'd witness powerful bullets of energy, individual gamma rays, from cosmic phenomena such as supermassive black holes and hypernova explosions. The sky would be a frenzy of activity. Before Fermi was launched in June 2008, there were only 4 known celestial sources of photons in this energy range. In 3 years, Fermi has found almost 500 more, says Thompson. What lies within this new realm? Mystery for one thing, says Thompson. About a third of the new sources can't be clearly linked to any of the known types of objects that produce gamma rays. We have no idea what they are. The rest have one thing in common: prodigious energy. Among them are supermassive black holes called blazars, the seething remnants of supernova explosions, and rapidly rotating neutron stars called pulsars. And some of the gamma rays seem to come from the Fermi bubbles, giant structures emanating from the Milky Way's center and spanning some 20,000 light-years above and below the galactic plane. Exactly how these bubbles formed is another mystery. Now that the first sky map is complete, Fermi is working on another, more sensitive and detailed survey. In the next few years, Fermi should reveal something new about all these phenomena, what makes them tick, and why they generate such unearthly levels of energy, says David Panek, a leader in this work from the Max Planck Institute in Germany. For now, though, there are more unknowns than knowns about Fermi's world. Says Thompson, it's pretty exciting. For more science news from the edge, visit science.nasa.gov. NASA's Cure for a Common Phobia, presented by Science at NASA. NASA has found a cure for a common phobia, the fear of asking, quote, stupid questions. It's not a pill. No therapy is required. The cure is a rubber chicken? School kids, and even their teachers, can find themselves tongue-tied when they come face-to-face with an astronaut or astrophysicist. This can make it more difficult for NASA to reach out, inspire, and educate. But nobody's afraid to talk to a rubber chicken, says Romeo Dersher of Stanford University, executive secretary for a NASA ambassador named Camilla, who's taking classrooms by storm. Camilla knows there's no such thing as a stupid question, says Dersher. Outfitted in her own personal spacesuit, Camilla travels far and wide to meet with kids at schools, science centers, and even sci-fi conventions. She helps break the ice for astronauts and other space celebrities when they meet the general public. Camilla is the perfect NASA spokeschicken, says astronaut Clayton Anderson. I'm one of her biggest fans. Always a big hit with the kids. She makes science, engineering, technology, and math seem appealing, not threatening, to youth of all ages. Camilla's willing to go almost anywhere for science. Earlier this year, she flew to the edge of space to investigate a solar radiation storm. A group of high school students in Bishop, California attached radiation sensors to Camilla and sent her into the storm clinging to the payload of a helium balloon. She flew so high, 124,000 feet on one flight, that the daytime sky turned as black as night. Later, Camilla parachuted back to Earth, where the kids continued to study the data she gathered. We had so much fun working with Camilla on this experiment, says Rachel Molina, a senior at Bishop Union High School and a member of the launch team. She is one cool rubber chicken. One of Camilla's prime missions is to inspire girls to enter the sciences, and it seems to be succeeding. Molina plans to major in physics when she goes to college next year. Should I ask Camilla for a letter of recommendation, she wonders? More than 20,000 people follow Camilla on Facebook, Twitter, and Google+, where every adventure is an opportunity for science education. During one visit to Johnson Space Center, Clayton Anderson showed her the space toilet trainer, Dersher recalls. Camilla insisted on trying it out. She ended up getting sucked into the hose and stuck in the toilet. Luckily, we were able to free her, and we used the incident to teach how space toilets work. On November 14, 2012, Camilla will be in Australia to observe a total eclipse of the sun. At the end of totality, she's going to run the Solar Eclipse Marathon, a 26.2-mile race that begins when the first ray of sunlight lances over the edge of the retreating moon. As far as anyone knows, this is the first time a rubber chicken has run such a race. Camilla's travel budget is very small, so certain measures are necessary for reasons of economy. For instance, on airplane flights, Camilla travels in the overhead compartment. I ask her to keep quiet, says Dersher, but every now and then she lets out a disgruntled squawk. I just sit there like I don't hear anything. Ultimately, Dersher would like Camilla to join the crew of the International Space Station. In particular, he's angling for a berth on Soyuz Expedition 4041. If this happens, astronaut chats from orbit with school kids and reporters might never be the same. With a spacesuited chicken floating in the background, no one will ever be afraid to ask a so-called stupid question again. For more fun news about space, visit Camilla's favorite website, science.nasa.gov.